All right, guys, so we just finished our unit on linear relations, where we learned all about graphing straight lines and the equation y equals mx plus b. And what we learned about this is we can find the slope of each equation, or the slope of each line, and the y-intercept. But now we're going to take a look, because not all graphs look like this. Right, so we're going to take a look at what are called quadratics, which graphs are going to look more like this. Okay, so we're going to be looking at curved lines. So what we're going to do is we are going to take a look at an example. So if we were going to model someone that was throwing a football, we would kind of take a look at it like this, right? We would start at, sorry, I just kind of yelled. So we would have height over here. So we don't know how tall the person is, and we could have distance this way, in which the person throws the ball and it goes up and down. We could also have an example where the person throws it higher and shorter. Or we can even have an example where it goes almost more like that. Right? So they don't really get it high, but we can see that it can be all different kinds of what these are going to be called are parabolas. Okay? So if we take a look at this here, we're going to draw a diagram of 3 different basketball shots. So for this to go in, this guy could throw it up and in the net, or he can get it higher and in the net, or he can even get it and miss the net. Right, so we can see that each of these are going to be a curved line. So if we give ourselves an example of a specific, like a specific example. So we have the ball reaches a max height, so it goes up about 8 feet, and it's 12 feet from the player, right? So if we make a graph, we're gonna go right through this guy and over, and we have it at about, we'll go with about 20-ish here, and we have him at about 6 feet, right? So we'll just go, so we have 5, 10, 15, and then 20. So we're going to go where it is a max height of 8 feet. So if we have this being about 10 feet, give or take 8 would be just underneath. I mean, 6 feet, but we're gonna go with here, because if we go any lower, we're not going to hit it in here. So we have it going from him to max height would be 8 feet, and it is at about 12 feet from the player. So I'm gonna have to move this over a little bit. So the max height is 8 feet, and it is about 12 feet from the player, and then when we draw it, is going to go in like that. So this is the max height, right? This is the highest point. Okay, right here. That is going to be the highest point of our graph. Okay, so then if we take a look at another example, a person jumps off at a 10-meter high diving board. they reach a maximum height of 14 meters after 2 seconds. They land in the water after 6 seconds, and their path is parabolic. So again, that means we're going to go up and down, right? So when a person jumps off a diving board, they're going to go up, and then down. So when we take a look at this, we're going to underline that it is 10 meters high that they start, right? This is their quote unquote starting point. And then it is 14 meters after 2 seconds is going to be their maximum height. So when we draw this, right, we're gonna put our, I guess I can continue to use this, we'll go 2, 4, and 6. So this is going to be time. Okay, and then we're gonna have about 10 meters here. So this is their 10-meter high diving board. And we'll need about, because we have 14 meters here, so we're gonna need to put a 14 up there. So when we graph this, we need to make sure that our highest point is at 14 meters after 2 seconds. So we're gonna put our point here, okay? And then we're going to graph it, so it starts at 10. See, it starts at 10 meters high, so we put our first point there. And the maximum height is 14 meters after 2 seconds. So then we are going to graph this as a parabola. And then it comes down about here. Right, so what we're going to see is this is, let me go down here, the highest point, okay? And if we continued to go this way, it would keep going, and this would be at about -2. So each side, I know my parabola is not very symmetrical, but a parabola has symmetrical sides. So if you cut it straight down the center, this is going to be the same on both sides. So when we take a look at this, so this is height, right? And we have a 10-meter diving board. What we're going to be looking at, I'm going to make this a different color. This graph has all different parts to it, okay? So this part here is our max value, right? It's our max height, which is also known as the vertex, right? So when we take a look at what that point is, it is x is 2 and y is 14. So this point here is called our vertex. Okay, that's what we're going to be referring to it as. And this dotted line down here that I did not draw very well, that is called the axis of symmetry. And our axis of symmetry is x equals 2. Okay, so the axis of symmetry is straight down the center, and that's when our x is 2. So from our graphing the straight lines, we know that our starting point, so when x is 0, right, y is 10. So this right here is going to be our y-intercept. And this is our starting point. Okay? And then we know that we have a point here, and we have a point, sorry, there's a point here, and we have a point here. So these are what they are called, are zeros. So these are zeros, which are our x intercepts, okay? Where it crosses the x-intercept. So it is at 6. So we have 1 at 6, and we have 1 at -2. Okay, these are our x-intercepts. So one thing about a parabola is it can go either up or, down. So this, like, it can open down, or we can have it where it opens up. Okay, they don't always have to be this way. They can be this way as well. So if we take a look at our next example, a tree is next to a lake. A bird is on a branch 3 meters above the ground. The bird swoops down in a parabolic path to catch a fish 1 meter under the water and 4 meters from the tree. The bird exits the water along a symmetrical path. And so we're going to put numbers on our sketch and label the key features. So we're going to do this here, in which we have our 1, 2, 3, and then we have 1, 2, 3, 4, 5, 6, 7, continue. Okay, so our initial height is at 3 meters. Okay, and then we go to, it catches the fish 1 meter under the water. So we need to go 1 meter under the water and 4 meters from the tree. So the tree is here, so it goes 1, 2, 3, 4. So it catches it here. Okay, and then when we draw our our parabola, we're going to go, again, this is probably not going to be very good. So that's going to be its lowest point, and I did not even touch it, but we're going to pretend that I did. And then it's going to be symmetrical up. Again, my parabola is not very pretty, but we get the gist of it. Okay, so we're going to take a look at our points. So we're going to take a look at our initial height. So this one here is our y-intercept, right? This is when x is 0. And then our vertex, so our either maximum or minimum point, right now it's our minimum. So this is our vertex, which is the lowest point. I don't know why. Vertex, which is the lowest point. Right, it's going to be either our highest point on our parabolas that open up. So it'll be our highest point on those ones. And it'll be our lowest point when it looks that way. Okay? So we have our vertex. So our vertex is at... Sorry, papers are falling off everywhere. When x is at 4 and y is at 1. And then we also have our x-intercepts, so our zeros. So we have one here and we have one here. So this one is at about, it's just after 2, so we'll say it's at about 2.2. And this one is 3, 4, 5, 6. So give or take 6.5-ish. Okay, so these are our zeros. These are where it crosses the x, it crosses the x line. Okay. So now you guys have a practice sheet as well. What I'm going to get you to do is I'm going to actually get you to try these on your own. And I'm going to put the answers up online for you to double check if you got it right.